Welcome back to QFitsView. In this video we'll cover miscellaneous functionality that hasn't been covered in other videos. The first one we'll look at is the 2D cut, and this works on images. I'll load up one of the images, and then the 2D cut is selected through ImRed, Analysis, 2D cut. I'll just move this to the side a little bit so we can see what's going on. As with the elliptical profile discussed in a previous video, you can move the center position that you wish to cut along, and then you can rotate in any direction you like this, by grabbing on with the mouse to the cut direction. So you get the center position in the X and Y, you get the angle, and as you can see we have a profile that is already viewed. You can set the width as you like. For instance, I'll set it 3 wide, and you can store result in a new buffer. We'll just do OK, and there's your profile. In a similar way, we have a function for a 3D data cube, which is the Pseudo Longslit function. I'll just open up a data cube, and then we do this through ImRed, Analysis, 3D Pseudo Longslit. As before, we can set the central position. Now, if you remember, this is NGC 5728, which has bicone outflows. So I'm going to set the cut angle along the axis of the bicone, which is about this sort of direction. About 49 degrees or so is fine. We can then do the same sort of things, and we just do OK. It takes a little time to perform. After the process is finished, we can see the 2D spectrum with the bright emission lines. There and there. I'll enlarge this so we can see the iron 2 line. There it is. And I'll change the color map to rainbow. And there you can see the velocity structure. This is essentially a position velocity plot. We can mark positions on the image. This is useful for locating points for photometry. I'll load an image of a globular cluster. And I'll mark some of the positions of the bright stars around the periphery. You just put a cursor over the center of the star like this. And as you can see, you can do that in the enlarged image as well to control fine detail. And then press the M key. And as you can see, it puts the location. At this case, it's pixel 587,99. And I can mark other positions. This. You continue pressing the M key on each position until you've finished. Now, you've got a choice of the method of finding the center. You can do pixel, which finds the maximum value location within the radius. You can do center, which is actually on the center of the location. You can do centroid, which finds the centroid inside that radius, or Gauss fit. You can clear all values by pressing the escape key, and you can also start marking with the ImRed mark positions function. And as you can see, it goes to the crosshairs. You can then create a new buffer from the marked values. As you can see, it uses either the centroid or the Gauss pos DP user function and creates a binary table with the values in it. The next function we'll cover is statistics on a region. I will open an image file and ImRed analysis statistics on a region. Now this gives you this statistic, which is the total number of pixels, the total value, average standard deviation, etc., etc. However, you can also mark a region that you want using the aperture marking keys as before, the S key, which produces this little green region, and now you can see it is just measuring the statistics on those 42 pixels. You can remove the selection area with the R key. A final point to make about printing: if you attempt to print the contents of a FITS file or a FITS data array, you get this sort of thing. So I'm going to print buffer 4. And what you get is a statistics on this buffer, statistics on the full array. Number of axes and array size and maximum values and so on. If you wanted to print the actual values, you do the command print, whichever buffer it is, /values. And as you can see, it prints all of the values in a great long number array. That's all for this video. Check out other videos on our YouTube channel.